The Saga pattern is a pattern that guarantees that multiple operations get done, although it doesn't guarantee that they get done as a single atomic unit. What I show on this slide here is a queue, and the queue has a few messages in it. Each message represents a sequence of actions we want to get done. These messages, I call them trip sagas. Let's say you're planning a trip, and when you plan a trip, there's probably three things you need to do. You want to reserve yourself a rental car. You want to reserve yourself a hotel reservation, and you want to go and book yourself an airplane ticket. Now, these are usually done by three different companies. The rental car company is one company, the hotel reservation is a different company, and then the airline is a third separate company. And if you don't do all three of these things, then you don't want to go on the trip, right? You don't want to take the airplane there and not have a hotel. And you don't want to have a hotel but not be able to get there because you couldn't book the plane. So we want to make sure that all three of these things happen, and only if all three do you really want to go on the trip. And because they're different companies, you can't do a distributed transaction across these operations. So this message in the queue says which rental car company we want to reserve a car, it says which hotel we want to reserve a room, and it says which airline we want to go and book a plane with. Now we want to perform these three things. So we're going to take this message out of the queue, and it's going to be handed off to what's called the Saga Execution Controller. The Saga Execution Controller is the piece of code that's going to walk through this information in the queue message, and it's going to communicate with the three other services to make sure that the work gets done. The Saga Execution Controller is going to attempt each of these three separate transactions, and it can attempt them in concurrent fashion. In other words, it could make a request to all three of these at the same time, which is good for performance reasons, or it could do it in risk-centric order. This is dependent upon you, how you want it done. In this case, we could probably make the transaction to the rental car and the hotel together concurrently, because if either one of those fails, let's say we rent the car, but we fail to rent the hotel, we could go back to the car rental agency and cancel the order, right? Or if we fail to rent the car, but we successfully rent the hotel, you can go back to the hotel and successfully cancel the reservation. But for an airplane, there's usually a charge involved with canceling a reservation if you can do it at all. So it has high risk involved in that. So so we could do the first two in parallel, and then only after both of those complete successfully, we can go and do the airplane last. On my slide here, I do everything sequentially just so we can talk about it in the slide. For fault tolerance, again, the operations may be retried, right? This is a theme throughout this entire course, is that we gain fault tolerance by retrying operations, and then on the server side, the operations have to be done idempotently. And with the Saga pattern, it's the same thing as we've been talking about before. The execution controller will retry operations against these other services in case they happen to be down or not responding or a timeout occurs. And if it retries the operation multiple times, we don't want to rent multiple cars. We don't want to rent or reserve multiple hotel rooms, and we absolutely don't want to reserve multiple airline tickets. So these servers have to be implemented internally to be idempotent against this. So the Saga pattern has two different recovery modes that are available with it. The first is called the backwards recovery mode. This is the one that I'll demonstrate here because it's the more complicated one to understand. So my animated slide will walk you through that one. In the backwards recovery mode, if any transaction fails, then we have to go back and undo any of the successful transactions. In the forwards recovery mode, we just keep retrying until we hit ultimate success. So this assumes, in the forward recovery mode, it assumes that you will ultimately be successful at accomplishing everything you intend to do. Okay, so that one's the easier one to understand. So let's go. The Saga controller first made a request to the rental car reservation service and said, please rent a car. And the rental car service said, okay, I have a record of that. This person has now rented the car. Now, because that transaction was successful, the Saga execution controller now goes to the next service, the hotel reservation service, and says, please reserve this hotel room. And the hotel reservation service says, okay, I will make a record of that. I have rented the hotel for you. Now the Saga execution controller goes to the airplane reservation service and says, please reserve this flight. But let's say the flight is booked and we can't get on the flight. So the airplane reservation service returns back and says, failure. I'm unable to do this. So now the Saga execution controller will go back to the airplane service and undo the operation. Now, you might think this is a little strange because it didn't successfully perform the operation. But this is because of retries and idempotency. It goes back and it still says undo it. And then, of course, it should be idempotent. So the airplane reservation system should say, well, you're trying to undo something that I never actually did. Well, that's success. And so the airplane reservation service responds back to the execution controller saying you were successful at unreserving this because logically the reservation does not exist. Then the execution controller goes back to the hotel and says, please cancel. And then it goes back to the rental car and says, please cancel. And now it's all been undone as if it didn't happen at all. And that is what the Saga execution pattern is all about. It's a very popular pattern, actually. But you need to have something really resilient here. The reason why we use a message queue is because the Saga execution controller could fail, right? This itself could fail. It's a single point of failure. And if it does, then the message will become visible again in the queue, and then the new Saga execution controller instance will pick up that message, and it should be able to walk through the steps and continue from where the previous execution controller left off in the case of failure to make sure that this either happens or doesn't happen in its entirety, even though it's not done as an ACID transaction.